Hello everybody, today we're going to talk about measuring center. So one ways that we measure center is using the median, which is the midpoint of a distribution, the number such that about half of the observations are smaller and about half are larger. To find the median, we have to arrange the data values from smallest to largest. If the number n of data values is odd, the median is the middle value in the ordered list. If the value n of the data values is even, then the median is the average of the two middle values in the ordered list. The other way we measure center is using mean. And you may have heard about mean before. It's just an average. We also can talk about mean as x bar. Okay, that's what this right here is. Of the quantitative data set is the average of all n data values. So to find the mean, what we're going to do is we're going to add all the values and divide by n. That is, x is the sum of the data values numbers of the data values. So we have this formula where we're going to take every individual data point here and we're going to add them all up and divide by the total number of data values that we have. Or, in a more mathematical way, we have that x bar is equal to the sum of all the data values divided by n. Okay, it's actually, you need to make sure you write this in your notes. The divided by n part is not there. Now, this may be new to some people. This is actually called a sigma. And when you see a sigma, I want you to think sum. Okay, because what we're really doing is we're adding up, that's what sum means, all of the numbers here, and we're dividing them by the total amount of n there are. Okay, and this is actually a capital letter for E in Greek. Okay, it's called sigma, and again, when you see sigma, I want you to think sum. What we want to do is we want to do an example here. So example number 9, did you skip a beat? A statistics instructor asked 15 students to record their heart rate while they were sitting at their desks. So here are the list of heart rates and their beats per minute, or BPM. And what we want to do is we want to find the median and the mean, and we want to interpret this value in context. So the first thing we want to do is we want to find the median. And in order to do that, we actually need to arrange all of the data in order. Okay? So what we want to do is we want to start in ascending. So we want to put the lowest number first, which it looks like it's going to be 47. So we want to put them all in order. And we're going to start with 47. And then after 47, it looks like 55. Do we have anything else in the 50s? Nope, but we do have two 60s. And then we have a 61. And then a 62. And then it looks like we have a 68. And then there's nothing left in the 60s, so let's go 70s. So we have 70, 74, 76. Doesn't look like we have anything left in the 70s, so we have 80s. And then 88. And then nothing left in the 80s, so let's go to the 90s. 96. And it looks like what we have left is just 100. So again, I like to make sure to recheck that I have them all here. You can do this by crossing out, and then just to be super safe, you can always count 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 numbers. So because we have 15 numbers, we have an odd number of data values. So that means the median is just going to be the middle value. So in 15 numbers, the middle value will be 8. So we're going to find the 8th number. 1, 2, 3, 4, 5, 6, 7, 8. It looks like 70 is going to be our median. Okay, and that means that there's going to be 7 over here and 7 over here. So that's directly right in the middle. Now to find mean, what we're actually going to do is we're going to add all of these numbers up and then divide by 15. So we're gonna add all of these numbers up. So we have 47 plus 55 plus 60 plus 60 plus 61 plus 62 plus 68 plus 70 plus 74 plus 76 plus 80 plus 88 plus 90 plus 96 plus 100. And we're going to divide all of those numbers when we get them by 15, which is our n. So what we're going to do is we're going to actually put that in a calculator. Okay. And I'm going to show you guys a couple tricks because your calculator will actually find all of these numbers for you. So what you're going to do is you're going to add all of these up. So when I added all of these up, I got 1,087 divided by 15, which is going to give you 72.5. So our mean, or x bar, is going to be 72.5 beats per minute. And the median would be 70 beats per minute. Okay, so again, you're just going to add all these numbers up and divide them by how many numbers there are for mean. And for median, you're going to find the middle number. Okay, so note that the mean is not resilient to outliers, but the median is. What this means is that if you have a number that is very, very big or very, very small, it's going to drastically affect what the mean is. Okay, so a measure of center or variability is resistant if it's not influenced by unusually large or unusually small values in a distribution. So the mean is actually pulled in either direction of the long tail in a skewed distribution. And the best example I usually give about this is what would happen if I asked the class what the mean of what you guys make in a month. Okay, so because you guys are students, I don't expect it to be very high, right? But if Bill Gates were to walk into the room, all of a sudden the mean of everybody in the classroom is going to jump exponentially, right? It's going to be very large because Bill Gates is an outlier in how much money an average high schooler makes, correct? So that's what I mean by when things are not resilient. However, if you throw an extra point in, like Bill Gates, the median would still be representative of how many people there are. So let's look at a couple graphs that I put here at the bottom. If you guys look at the first one right here, okay, when you have a skewed to the left distribution, the mean is going to be less than the median. Because what happens is this skewed tail here brings the mean closer to the tail. Okay, I actually like to think of this as an arrow, and when the mean is less than the median, then the tail is going to be towards the left side. Now, if you look over at this middle one, B, you'll see that this is pretty roughly symmetric, and the mean and the median are actually pretty close to each other. They're approximately equal to. They're not exactly equal, but they're pretty darn close, much closer than over here in this example. Okay, so when it's roughly symmetric, the mean and median are approximately equal to each other. And the last case we have is when the mean is greater than the median, then that means the skewedness is actually going to be towards the right. Because again, the mean will drag the point, the whole skewedness, towards itself. So again, with the arrow, if the mean is greater than the median, it's going to be more, it's going to be larger, it's going to be skewed to the right. Okay, so that is actually the end of today's lesson. This is actually a very important thing to remember. Okay, because you're definitely going to see this on a test asking about to compare mean and median together depending on skewedness or vice versa. And a lot of kids forget this little tiny piece right here. And you're also going to see it on your homework. So what I'd like you guys to do is I'd like you to go back to Google Classroom or to your blue folder, and I'd like you to try to complete the work for today. And that would be on measuring center. If you guys have any questions, of course, you can always email me or find me in the Google Meet during class time. Have a great day.